of these things. So in today's session, we'll be discussing regarding sequential and parallel blocks, and with the continuation with that, we'll be discussing the other parts also. So in Verilog, right, we have two kinds of blocks. That is, one is sequential and one is called parallel. The name itself tells that there is something to do with the sequential aspect. Sequential means one after the other, and parallel means in concurrent in nature. That is all together. So these two blocks, right, they pertain to the execution of the instructions what you have put forth in the code. So if you have, say, some 3-4 lines of codes, in sequential, what happens is the first one is executed, after that only the next one, and after that the next statement. Whereas in parallel, what happens? All three get executed in tandem. Uh, that is in concurrent this thing. So all together will be executed. So that is what happens in these two. Now, how do I identify that the blocks are sequential or parallel? So first we'll come to the sequential blocks. In sequential blocks, we use the keywords begin and end. So up till now, you have seen that we were using these things in the examples. So begin and end, we were specifying for the modules and other stuffs. So all those blocks, what you are defining, right? So those, if they are clubbed between and begin and end, or if there is only one statement, you generally don't use it. So in that case, what happens is when we group multiple statements using the keyword begin and end, we term that block to be a sequential block. So based on this keyword, I can identify that, okay, the block is pertaining to sequential blocks. Now, what happens in sequential blocks? In sequential blocks, so if I just happen to take the example, so if I just observe what I'm having initial and initial block is present. So in that I'm having begin and end. So this block is sequential in nature. So what does sequential imply? Once this statement, that is x is equal to 0 is executed, after that only y is equal to 1 is executed, after that z is executed, and after that w is executed. So that this is what is happening in sequential form of execution. Now your C programming is also sequential in nature. So that is, after first instruction is executed, next one, and after next one is executed, the next statement after that. So this is how it goes around. So that is the property, or that is the nature of the sequential block. Now, this is one exception which comes as the non-blocking assignments. So when you have non-blocking assignments, what happens is all the statements get executed at the same time. If you remember, non-blocking statements uh, are identified with, say, x is equal to this assignment operator and whatever value you want to specify. Say like this. So these are all non-blocking assignments. So non-blocking assignments, what they do is they don't block the assignment of the next operator. All of them execute at the same time. So these all things we have discussed in the previous sessions. So only for this one, except for this, right, the order of execution will be one after the other in the sequence what you have specified. So that is pertaining to sequential block. And here another thing to remember is that delay or the event control what we are specifying. So this delay or the event control is relevant to the simulation time of the previous statement. So here, for example, if I just specify, so here we have, so we have an instruction. So here we have begin and end. So this is a sequential block. This is a sequential block. We have the first statement x is equal to 0. Then what we have #5 y is equal to 1. So what does this imply is, since it is sequential, right, after x is executed, y will be executed. So after execution of this one, after 5 time units of delay, y will be executed. Now next one, what we have, it is 10. So what happens is, this is having no delay. This x is having no delay. So now what happens? 0 plus 5. So after 5 time units plus 10, so 15 time units, this will be executed. So plus 20. So it is around 35. So here, this completes the simulation at time 0 time unit. Then because of this one, right, 0 plus 5. So 5 time units it will be consumed for this execution. That is y is equal to 1. And then because this is consuming 5, this statement is dependent on execution of this one because it is sequential. So 10 plus 5. So it will be 15 time units for this case. And then it will be 35 units because it is 15. This up to this point, it is taking 15 time units. 15 plus 20, it will be 35 time minutes. So here, since it is say one after the other, these delays what you're specifying are dependent on the previous statements. Okay. And if it is continuous assignment, right, all are independent. All are independent. So if I consider it as say non-blocking assignment, non-blocking assignment. In that case, if these statements are correct, x is equal to 0 at 0 time unit, then y is equal to 1 at 5 time units, then z is equal to whatever value is there at 10 time units, not 15. In non-blocking assignment, it will be 10, and w will be equal to whatever value is there. Based on that, it will be after 20 time units, not 35 time units. So only that is the difference when you use non-blocking or blocking assignments. So that is one of the specifications what we have to look out when we are going for sequential blocks. Now here, what happens is if I just observe in this case, right, in the first example, what we saw, the final values are specified as x is equal to 0, y is equal to 1, then z is equal to 1, and w is equal to 1 at time 0. Now, since that is the first, this case, that part is pertaining to this one. So why he is specifying where that is, if you just observe, all of these start the execution at time t is equal to 0. But what is the intention over here? That x executions, x values execution, after this has been executed, then only y will be executed. So that is what is happening in sequential. So that is x is equal to 0 at 0 time unit, but all start the execution at 0 time unit. So therefore, what happens? Once x is executed, it goes to next. So which will be a very fast process. So after that, what happens? Y will be definitely 1. Since x and y have specific values, right? They have specific values now. Then z will be executed. X is what? X is 0 and y is 1. So 0, 0, 1, when they're concatenated in decimal, it turns out to be how much? It is 1. Then, so z will be 1, it is confirmed. Then w is 1 comma 0. That is 1 0 is concatenated, 1 0 is binary, and in decimal, what it turns out to be? It turns out to be 2. So at 0 time unit, what happens? The values will be in this form. And simulation will be executed at 0 time unit. So this is 0 time unit, the execution will be completed. And the same values will be even available for this one, but the execution time will be consuming around 35 units because of this delays what you have specified. So this is pertaining to sequential blocks. Then coming down to the next one, parallel blocks, the name itself tells that what happens. So in this case, these executions, right, will be happening at in parallel, whether it is say non-blocking or blocking assignment statement, whichever you are using. So the operation will be happening in parallelly. Operation will be happening in parallelly, or the instructions will be executed parallelly. So here, in order to go for that, what we do is, if I want to have the block in parallel in nature, we go for the keywords which specify as fork and join. So previously, what we did, we used begin and end. So instead of begin and end, we use fork and join. So what happens in such kind of parallel blocks? The statements are in the parallel block are executed concurrently. Concurrently means all are executed at once. All start the execution at once, whether it is blocking or non-blocking. Then ordering of the assignments is controlled by the delay what is specified. It is not dependent on the previous statement. It is not dependent on the previous statement. So whereas here what we said, y's execution is dependent on the previous statement. That is x has to complete its execution. But in parallel, right, y's can execute independent of x. There is no need to go ahead with these kind of things in parallel blocks. X, Y, Z, and W, what are specified, right? All can execute at any moment. They can execute parallelly. Nobody is dependent on the other this thing. Okay. So in here we have to be careful when we are dealing with parallel blocks, because we can fall in something called as race condition. So we'll just check out what is that. Now here the delay what you're specifying, right? Delay of the event control, it is related to the time the block was entered. That is, so this is the block. So the time period during which you enter. So these delays are pertaining to that. So at 0th time unit, you enter the block. You enter the block. So X will be executed at 0th time unit since no delay is specified. This hash 5 specified, right? It will be like 0 plus 5 at 5 time units. This will be executed. Then here it is 10, but this 10 value will be pertaining to the block time which it has entered. So it will be 0 plus 10, that is during 10 time units, Z will be executed. That is completion will be happening at 10 time units. Then 20, this 20 is pertaining to the time period during which the block was entered. So it is 0 plus 20. So W will be completing its execution at 20 time unit. So this is somewhat similar to your non-blocking assignments in your sequential blocks. So in parallel blocks, using the blocking assignments, I can have the feel of non-blocking assignment statements. So that is what you can look out for. So, but the keywords what you're using is fork and join. No need to use this operator. So without this operator also using fork and join, I can run the block as though it is using the non-blocking assignments. So this is what is happening in parallel blocks. Okay. So let us go for the next this thing. Now here, one thing to remember is what happens to the values of the X, Y, Z, and W. Z and W values are important for us now, because here I can see that X is directly assigned with 0 and Y is assigned with 1. Now, but what happens to Z and W since all start their execution at same time period? Now here, what happens is since all start the execution at same time period, right? That is at 0 time unit. But at what time it completes, that is different task. So here we can observe what happens is we can have something called as a race condition. Can have something termed as race condition, because the order in which they are executed, it is not known to us. So in this example, right here, if I don't specify delay, if I don't specify delay and instead of begin, I make it as say fork and if I use fork and join, that is I make this entire block as say parallel. If I make this black block parallel, then what happens in this case? Since no delays are specified, what happens in such cases? So here I am not assured that since all are independent of each other, I am not assured that which one will start its execution, which one will complete its execution, because it is totally dependent on the simulator, it is totally dependent on the system what you are using. So all these things. So here what happens is if X and Y are executed first, so X will be guaranteed to have 0 and Y is guaranteed to have 1. But all are executing at the same time, but the assignment, what happens to them? If there is a slight difference between them, then what happens is there will be a race condition which is existing. So if X and Y get simulated first, then what happens is X is 0 and Y is 0. In that case, what happens is Z will be 0, 1. That is, its decimal value will be 1 and W will be 1, 0. Its decimal value will be 2. Now, what happens if these two get initiated first? If these two, but these two are not initiated, because I don't know which one will be executed at what time. That is not under our control. It is under the control of the simulation or what you're doing. So it is that part. So in that case, what happens is I don't know if say Z gets its initiation. So X and Y initially I don't know the values. So it may be unknown. So it may turn out that Z will be a value of unknown values, X concatenated with X. It is not the variable X, it is the unknown value. Similarly, W also will be X and X. So this is the problem when we are dealing with parallel blocks. So delay elements have to be specified if such conditions come around. So that is what he is specifying here. The order in which the statements will execute. I don't know in which order they'll be executed. So if I don't know the order, the values of z and w in the above statements can be changed. Now, if x and y get executed first and then the other variables are assigned the values, then what happens is z and w will be having 1 and 2 as I mentioned. Now, but if z and values get executed first, if z and w get executed first, then in that case, since x and y values are not known during that time, both will be having unknown values. These x's are the unknown values. And after that, if this executes, then I have no this thing. So here it will be unknown. So this is actually the race condition which comes into existence. So whenever we are using parallel blocks, right, be careful with such kind of assignments because you are having dependencies on the variables. So you can put forth a delay or something and try to adjust the entire stuff, but it should be dependent on the design what you are looking for. Okay. So this is pertaining to the sequential and parallel blocks. So here that is the race condition what we have discussed, right? That is what he has specified. So here we have that race condition, fork and join. Okay. So since delays are not there, I don't know which one will start its execution first. If these two start, the values will be unknown. But if these two start, then Z and W will be 1 and 2 respectively. So that is what we are looking out for. Okay. So next we have special feature blocks. In that we have nested blocks, named blocks, and disabling the named blocks. So nested blocks, the name itself tells that I can have blocks which can be nested within each other. So here sequential and parallel blocks can be mixed up. So in these cases, so the blocks can be nested. So here we have an example of this one, that is we have an initial, begin and end. So this entire block is actually sequential in nature. Inside that I have another this thing, that is fork and join. So this is a parallel block. So what is happening within, say, the sequential block, I have nested the parallel block. I can have nesting of blocks in general. I can have nesting of blocks. So next, what is meant by named blocks? So the name itself just specifies that the block can be given a name. The block itself can be given a name, and that name can be used for further details. So here we have look if we have this kind of definition, right? Then what we have is the local variables can be declared for the named block. We can define the local variables for the block what you have put the name for. Then the named blocks are part of the design hierarchy. So what does this imply is if you remember you have hierarchical names, right? So that is made available when you name the block. That is, if I want to say get access to one of the parameters or one of the variables in that block, right? If in another module, so I can go for hierarchical naming in that, and then I can access that variable. So that is referencing what we specify, hierarchical name referencing. So that is what we can do in these cases if you name the block. So that will just check out how we can do. An example is there. So then name blocks, they can be disabled. That is the last part what we'll be looking out in this case. So that is the execution can be stopped in between. Now here we can just see a name block. We have module top, initial. Here we have begin and end. Okay, so this is your sequential block. Now this block is given a name as block one. So this is a block, this is the named block. So this entire thing is a named block. And apart from that, it is also sequential. So therefore it is sequential block named block one. And in that you can have a number of things. Now here integer I is static and local to block one. So this I is local to only this one. So it is like you are writing a main program or you are writing a function and you are declaring an integer in that, or you are declaring a variable in that. That variable is only local to that function or the main function. So in a C programming, so similar kind of thing. So if I want to access it outside this block, right? This block one, I can use this name block one and then access this. So how do I go ahead? So I specify this block is present in top module top. So here I write top. Under that top, what is there? We have block one. So top dot block one. And next after that, what I want to access, I want to access this variable. So it is top dot one block one. In that block one, I want to access this variable. So this is how you access it. So this is hierarchical naming or hierarchical referencing what you are providing. Okay. So if I name the block, this is the advantage. If I don't name, then I cannot access this variable in this form. I cannot access it. So that is the advantage of named blocks. So here there is another this thing what he has given. He has given fork and join. So this is a parallel block, and the name for this block is what? Block 2. Parallel block, which is named as block 2. Then under that, I have one variable register 1. So again, remember this is actually local to this block. Now, if I want to access this variable outside this block, right? Then how do I go ahead? I can go ahead by hierarchical naming. That is, in the top module, block 2, I want to access this one. So it is top dot block 2 dot I. So this is what happens in this case. Now, if I want to disable, right, disable these named blocks, since naming is there, I can disable these named blocks. If naming is not there, then I cannot go ahead with such kind of disabling. So in order to do that, I can use disable keyword, but I can disable those also, but in different way. So here we make use of the keyword disable to disable the named blocks. So remember the term is named blocks. If you have named it right, then you will be using this keyword and specifying which block you will be disabling. Now it is somewhat similar to the break statement what you use in your C programming. So what does the break statement do? Break statement breaks out of the current loop in which it is executing. So for example, if you have say a for statement, and in that you have another for statement, and in this for statement you put a break statement. So what this does is this break exits this for loop, exits this for loop, but it will be still there in this the previous one for loop. It will be still there itself. So this break statement will be falling out of the current loop in which it is executing. So disable actually in this case, what happens is in if you use the disable right, it will be exiting that block. It will be exiting that block itself. Okay, and it will be disabling the named block what you have specified. Okay, so here we have an example. So here we have declared a register, then an integer is specified. So here you have a block, initial block, begin and end. So this one is sequential. So you assign some value to the flag. Then I is the count what he is using. Then here is the block name what you are specifying. Is the block name what you are specifying. The main block which is inside while is named block 1. So here you have what? While I less than 16. So you go until from 0 to 15, and when it becomes 16, right, you try to come out of this loop. Or so that is the conditional statement. Begin if flag is set. So if flag of I is set, right, then what you do is you have seen that the bit is 1. So if the bit is 1, what you're doing is you are disabling this block. Disable block 1 because you have found some erroneous thing or something you are doing over there. So if that is not the case, then you continue with the execution of the while loop. So this entire thing, right, will be continued either if none of the bits are set or if the count goes up to 16. So that is what happens. But if one of the bit is set, so in this case, we can see that this bit is set. So it will keep on incrementing when it comes at this position, right? It sees that the bit is set. So it will display a message and it will disable the block 1. It will disable this block 1 and it will come out of that block. So this is what happens in case of disabling the named blocks. So that is what is happening in this case. So